Hello student, today we will discuss the right hand rule and the relation between linear velocity and angular velocity, then relation between linear acceleration and angular acceleration, then uniform circular motion, non-uniform circular motion. So first here we take the right hand rule. So we know that the right hand rule already discussed. Suppose this is the right hand and these are the four fingers and this is the thumb. Suppose imagine these fingers are curved like this. Then this thumb shows the direction of angular velocity, angular acceleration and angular displacement, and this finger shows the direction of circular motion. So this direction is anti-clockwise direction. Suppose here we take the clockwise, then finger then it is like this, it is a reverse condition. So therefore it is a circular motion. So circular motion is performing by the curved fingers in a direction. Which direction? It is a clockwise direction, and thumb shows the direction of angular velocity, angular acceleration and angular displacement. Okay, so this called as right hand rule. Then again, suppose these three fingers by the right hand rule, this finger shows the angular velocity, angular acceleration and angular displacement in a vector quantity. This finger, first finger, it shows the direction of radius vector. It is only the radius vector. This finger shows only radius vector, and this finger shows the all quantities on the circumference. Circumference मध्ये जेवढ्या quantities असेल तर त्या quantities या फिंगरनी, मिडल फिंगरनी आपल्याला शो करायचे आहे. त्याच्यानंतर समजा इथे आपण त्याचा एक डायग्राम काढू. इथे समजा एक सर्कल इथे आपण कन्सिडर केलं. This is the center point and this alpha, del theta and it is a omega, and it performing in a anti-clockwise direction. So this shows the right hand rule in a anti-clockwise direction. So therefore it is, this condition is anti-clockwise direction. And clockwise direction, suppose again this circle, center point, and it shows the downward direction. So it is a downward direction, and the direction is, this is the del theta, alpha and omega. So it is in clockwise direction. It is most important for the objectives. याच्यावर काही ऑब्जेक्टिव्ह विचारू शकतात कधी कधी. क्लॉकवाईज अँड अँटी क्लॉकवाईज द डायरेक्शन फिगर दिलेली असेल आणि त्या फिगरवरून आपल्याला नोट करायचं आहे की क्लॉकवाईज डायरेक्शन जर असेल तर मग त्यामध्ये अँग्युलर वेलॉसिटी, अँग्युलर ॲक्सलरेशन आणि ओमेगाचं डायरेक्शन काय आहे, आणि जर अँटी क्लॉकवाईज असेल तर त्याचं डायरेक्शन काय आहे. सो इट इज अ अपवर्ड डायरेक्शन अँड दिस इज द डाउनवर्ड डायरेक्शन. देन अगेन हियर one point we have to recall. Suppose when the particle is performing circular motion, clockwise or anti-clockwise direction. Suppose here we take the example of fan. Suppose fan is switched on, then what we get, the blades are performing circular motion and the initial angular velocity, it is given by omega 1 is equals to 0. Then after some time is t, then it has a constant velocity omega 2 is equals to, it is considered as, here I consider suppose 2 radian per second. Then what is angular acceleration? So therefore alpha is equals to, it is a final velocity, angular velocity minus initial angular velocity divided by time is t. Then in this condition, here we take 2 minus 0 divided by t, so therefore alpha is positive. Alpha is positive. So in this condition, when the alpha is positive, then the right hand rule shows the direction of angular acceleration, angular velocity and angular displacement. It is a upward direction. So there is a upward direction. So this thumb shows the direction in upward. Okay. If the reverse condition, so it is omega 1 is equals to, suppose here consider 2 radian or suppose 20 radian per second, and omega 1 omega 2 shows the 2 radian per second. Then alpha is equals to omega 2 minus omega 1 divided by t. So therefore alpha is equals to, so here we get 2 minus 20 divided by t. So therefore alpha is negative. So if alpha is negative, then the direction of, again the direction of, so here direction is upward direction, so therefore here we get alpha, del theta and omega. But when it is a negative, then the direction in circular motion, suppose here draw the diagram, center point, so this upward direction in anti-clockwise direction, so therefore it is del theta, alpha and omega in upward direction. But when alpha is negative, then the direction of alpha in a downward direction. So therefore it is alpha, direction of alpha is downward direction because it is a negative. If in clockwise direction, this condition, here we take the clockwise, then to at the clockwise direction, here we get same condition. Suppose alpha is negative, then at clockwise direction we get, in clockwise direction we get the right hand rule like this. So the direction of this thumb in a downward direction. So therefore here we get del theta, omega and alpha. So these are the direction. If the alpha is negative, then here I remove this in a clockwise direction. So therefore the alpha is negative, then the direction of alpha is upward. It is the upward direction in clockwise direction. If the alpha is negative in clockwise direction, the direction of angular acceleration is upward and angular displacement and angular velocity is downward direction. Here alpha is negative, but in a anti-clockwise direction, the particle is moving anti-clockwise direction. Therefore angular displacement and omega is upward direction and the angular acceleration is downward direction. तर यावर सुद्धा आपल्याला ऑब्जेक्टिव्ह कधी कधी पेपरमध्ये विचारतात. तर हे पॉईंट्स तुम्हाला राईट हँड रूलमध्ये आपल्याला रिकॉल करायचे. ओके. सो नेक्स्ट इज relation between linear and angular velocity. So suppose here I consider a particle, one particle is performing in circular motion and center point is O, and here draw the radius vector. Suppose this is the radius vector and this is the particle on the circumference. Then suppose this particle is moved from point A to point, suppose here considered as a B point. So at B point, then again I draw the radius vector from center to the circumference. Then this radius vector is R, and here we get the angle, and this angle is delta theta. It is called as angular displacement, angle traced by the radius vector. Then suppose when the particle is performing circular motion, then at the tangent we get the linear velocity, or it is called as tangential velocity. It is given by v, and here also we get the tangential velocity. It is, suppose it is v is the tangential velocity. Then here we get from A to B, it is the arc length, so it is called as arc length del S, and this shows, because it is the anti-clockwise direction, so therefore this shows the direction of angular displacement alpha and omega according to the right hand rule. So we have to calculate here the relation between angular velocity and angular acceleration. So we know that suppose the particle is moved from A to B, then we get here angular displacement del theta. So according to the definition of angular displacement, the arc length is equals to radius vector into angle traced by radius vector. So angle traced by the radius vector. So this is the equation for the angular displacement, and therefore we get here arc length is del S, radius vector is R, cross into del theta is the angular displacement. So if it is the instant change, therefore here we take the instant change. Suppose this is our sun at the center point and it is our earth. Then there is the instant change with time is del t. So therefore here we take the instant change and the time is del t. So therefore this equation is divided. So it is divided. Equation is divided by del t, and taking the limit del t tends to 0, then we get the equation del S upon del t equals to R into del theta upon del t. But sorry, so here we take limit del t tends to 0, so therefore limit del t tends to 0 into del s upon del t is equals to limit del t tends to 0 into r into del theta upon del t, del theta upon del t. So therefore here we get the formula again, limit del t tends to 0 into del s upon del t is equals to, r is constant because at any point when its magnitude radius vector मध्ये तो जर त्याचं जर मॅग्निट्यूड आपण कन्सिडर केलं मॅग्निट्यूड, सो द मॅग्निट्यूड इज ऑलवेज कॉन्स्टंट ॲट एव्हरी पॉइंट, ॲट एव्हरी पोझिशन radius is constant, so therefore radius vector is constant, so therefore here we take the magnitude only, not direction, so therefore r is constant, so this constant is आपण या कॉन्स्टंटला लिमिटच्या बाहेर घेऊन घेऊ, सो इट इज वेक्टर it is r into limit del t tends to 0 into del theta upon del t. Then suppose here remove the limit, then after removing the limit again this formula it is given by ds upon dt. ds upon dt is equals to r into d theta upon dt, d theta upon dt. So therefore ds upon dt means it is the arc length. Suppose there is a instant change, suppose here consider suppose it is the sun and it is our earth, it is a very large distance, so it is a very large circle, and there is some instant change, then suppose this point is a point, considered as a point, and it moved to the at b point, so this considered as a b point, then here we get it is only a straight line, here we get the straight line because there is the instant change and there is no fixed displacement, it is a very small displacement, time is very small, then displacement is very small, then it considered as a straight line. So therefore if it is a straight line, when time is t, then we know that the displacement divided by time means the rate of change of displacement with respect to time is called as velocity. So therefore this formula written as ds upon dt is equals to v equals to r into d omega upon dt means the rate of change of angular displacement with respect to time is called as angular acceleration. So therefore this equation is omega. So this is the relation between linear velocity and angular velocity. So v equals to r into omega. This equation is very important. At every equation by theorems and any problems numericals, we have to use this formula v equals to r into omega. And if here we take in vector form, this equation is in vector form, then here we write in vector form, it is given by vector v is equals to, so these three quantities are in vector quantities, so therefore वेक्टरचा जो प्रोडक्ट आहे तो वेक्टरच असतो, त्याच्यामुळे वेक्टर इज वेक्टर, सो देअरफॉर हियर two vector, the product of two vectors is called as cross product, so therefore here we get the cross product, but this cross product is given by again the right hand rule. Suppose again I considered here is the linear velocity because it is a circumference, so So it is linear velocity, angular velocity. So here we get angular velocity, and this is the radius vector, and it is the product of these two fingers, thumb and first fingers, and therefore this is the velocity v omega, and it is a radius vector. Then we get the formula vector v equals to vector omega cross vector r. So again we get this formula vector v equals to vector omega cross vector r. So this equation is the relation between linear and angular velocity.